Hello, good morning. Thanks for joining this webinar. Let me move to the next slide. I'm going to make, I'm Diego Soto, Chief Marketing Officer of Quobis. I'm going to make a short introduction of the company. I'm going to introduce the contents of the webinar. Later, my colleagues Santiago Troncoso and Marcos Cereijo will follow with all the slides and all the topics that are included in the contents. Just to make a short introduction of the company, you probably know this. We are based in Spain, currently 36 people. Focus on WebRTC. We have been working for a long time helping telcos and large companies in complex projects of VoIP, voice and video interconnection. And during the last 4 years, we were focusing on WebRTC. Working with vendors and helping telcos and large companies to deploy the first WebRTC solutions, okay, with different use cases. Our involvement in the technology, as we started really early, we had the opportunity to work in the standardization. So we were quite active in different standardization bodies like the ITF and others. In fact, we are the authors of some of the standards that are being used by the industry in general in order to manage signaling in WebRTC and so. At the same time, we were quite active in different industry associations. This is the case of the GSMA, Forum, and so, in working groups related with WebRTC. And we had some involvement trying to adopt and publish open source solutions. This is the case of Quobis. That was one of the first open source JavaScript stacks for WebRTC. Using Sippo over WebSocket, that was one of the signaling protocols that we were offering. Moving to the next slide is just to make a short introduction of the people that are working in pre-sales and that are helping you or partners to have success in all the proof of concepts and tests and efforts that we are doing to close some projects. These first slides are the guides, my colleagues that are managing support for all these pre-sales that are helping you to work in proof of concepts and demos. This is the case of Santiago and Marcos that we will talk later, and Jose Maria, Chema, and Marga that are helping you in order to have success with these demos and trials. In the next slide is our sales structure. Here, this is something that is new. We are splitting the world in 3 areas. David Puig is managing our sales in Spain. So he's the guy that is working with our partners in Spain. And in the rest of the world, we have Elias, who is managing the relationship with partner and leads and opportunities in EMEA and Asia. And Álvaro Ramirez that is doing the same, but in this case in North America and Latin America. In this slide, we have, before sharing the microphone with my colleagues, the topics that we have for today. Probably all of you know that we have 3 products: the Sippo WebRTC application controller, that is our application server, and Santiago will try to introduce the basic concepts and how to work in installations, configurations, and support of this element. We will be talking about the features that are available in the Sippo WAC and in the applications that we have. And we'll focus in two additional points. What's new in Sippo 3.0, that is the last release that we have, and what you can expect to have in our demo platform. Splitting all these contents in different sections. Here we have 6 sections. As you can see at the end of the webinar, we have some minutes to answer all the questions and so that you may have. But in any case, you can use the GoToWebinar tool that, well, you can use this tool to send all the questions that you have in real time. And if it's possible, we will try to answer as soon as we receive this. Okay. So I think that now is time for Santiago, so you can follow with the Sippo WAC introduction. So Santiago, now it's your turn.
Okay, thank you very much, Thiago. We are going to start the webinar, and we are going to start with the WAC introduction. Okay. So on this section, we are going to do a short presentation about the product itself and the family, and also a brief view over the possibilities that are enabled with this product. First of all, we are going to focus on the role of the WebRTC application controller, the Sippo WAC. And the question is that the WAC enables integration for the WebRTC applications with existing networks of IMS or also with other networks. What we focus and we want to explain from the very first beginning is that the Sippo WAC is not a WebRTC gateway. We use third-party WebRTC gateways, but we are not a media handler of the WebRTC environment. We orchestrate and move around all the elements that are required for these WebRTC scenarios. So we are going to enumerate the hit points. The one is the WAC hides the complexity of the different implementation of WebRTC. It includes through the Sippo.js stack different abstractions of the methods that are implemented for WebRTC on different browsers and also with different platforms. We are signaling agnostic. We implement and work with most of the industry WebRTC gateways, and we did interoperability tests with all of them. And we manage different signaling protocols. Also, like we have on the number 3, like we have the application hosting on a specific server or service, we can implement security mechanism that allows to implement a defense or a mechanism against traditional voice over IP attacks on one side, and also with pure web and WebRTC different threats. Also, the WebRTC applications are developed over the Orca.js. As Diego said, it's an international initiative to make all these applications or all these layers, all these APIs, interoperability with different vendors, and with only one code you can implement it for different WebRTC gateways. We also create interconnection with existing systems through the Sippo connectors. We can consume external REST APIs exposed for both proprietary and also standardization services, like could be items related with accounting, with presence, with integration with CDRs, and so on. And also we could receive that information from them. It's a nice point on the web. And also we have the ability to implement multi-tenancy environments where with one program and several customers you can serve different kind of applications based on the same infrastructure and also based on the same use case. I think that this could be clear, and now that we have the main topics on mind, how we prepare the architecture on a very high level. Okay, we have the Sippo WAC, the WebRTC application controller, as a separate element, and we orchestrate the communication that is made between the different endpoints on the left side, the different web endpoints, using the WebRTC technology, with the endpoints on the right side, where are the legacy network and also the different architectures that could be maybe on the service provider or maybe on the enterprise that is integrating this use case. So we create applications over Sippo.js. These applications are served as HTTP. That could be founded on the upper left corner, that connection. And these applications uses the WebRTC signaling and media configured for this gateway. We say that the gateway is a third-party element to provide all the signaling. But all the services that we have and the use cases that we are going to explore during this webinar are usually connected with some kind of external service like an LDAP, maybe an authentication system like OAuth, maybe a voice network where a PBX or something needs to have a presence or information about the elements that appear on the website, and we manage the Sippo connector and the service API that we expose. Okay, there is a little difference. The Sippo connector is something that from the WAC are requested that are sent from the WAC to the external services, and the service API is a fixed API that is served from the Sippo WAC in order to maybe to gather information or maybe to implement some kind of commands, like for example to start records or something similar. Okay, so this is a example diagram that I think that represents the two levels that could be appear. Okay, the gateways are offered by the different vendors. Like, okay, here is my gateway, and you have an API where you can build your application. What we did is to abstract that different APIs or different libraries from different vendors and use a unique library in order to gather to provide all that applications. In addition, we used a fixed server where we can implement all the contextual elements that are required to make that communication possible and also to make that thing really useful. Okay, on the next slide, we try to represent the Sippo abstraction layer, the Sippo.js. And with this abstraction layer, we created two main applications: the Sippo Web Collaborator, the unified collaboration tool, and the Sippo Click-to-Call. The Sippo Click-to-Call is a jQuery plugin that is embedded on different web pages in order to provide a WebRTC endpoint. So On one side, this Sippo.js library on the left side, it abstracts for the complexity that appears on different vendors, different signalings that are used for the different. No, sorry, excuse me. On the left side is the media API, is the different browsers, platforms, and devices, and there we the WebRTC specifies some methods, but all the manufacturers do slightly changes between them, and also they included sometimes like in the case of Safari or Internet Explorer, they do not support it, so we need to add an extra layer or so on. Something happens similar on iOS and Android and so on. So that little differences between the implementations are contemplated inside the Sippo abstraction layer, the Sippo.js. And on the right side, we implement that third-party dispersion or complexity that appears on the real scenario, that are the different signaling ways, like for example, SIP over WebSocket, a REST API, maybe a proprietary API, something related with JSON, and so on. We use it, we understand, learn, and implement the different APIs. We use it, the proprietary APIs that are provided to us from the different vendors, and we abstract all of them into the Sippo.js. The result is that your application is more simply to be built. You have one method to make the register, for example, another method to create a call, another method to create a whiteboard, another method to create a chat session, and so on. And you can forget about all the complexity and the different elements and the scenarios that you have all surrounding your application. You only focus your development efforts into create the application. Okay, that's the Sippo concept. The Sippo.js is based on Orca.js. It's a standard. It's a reference that was created from an initiative of these vendors that appear on the slide, and was created and defined in order to avoid the vendor locking and to create a standard to these APIs. So what we did is to participate into this consortium. We adapted this solution to include extra elements and extra methods that does not being covered by the Orca.js library, and we created different aspects that are not references into the Orca.js. But in the basis, if you have your application built over Orca.js, it will work with Sippo.js. Okay, we have a Sippo.js reference if somebody is interested to create a specific application. And the Sippo modules here are the other elements that are important for the Sippo WAG, and are pieces of code and features that are pre-built and could speed up the development of a specific scenario solution. So, for example, if you start from your vendor API and you want to create an application that do the classic things, well, the classic things are already implemented on the Sippo modules. Okay, they are implemented as services, and we will see on the technical part of this webinar how these different services are organized and implemented. What's the difference, and what are the different options that we offer? we build applications, so we sell these two final applications: the Sippo Web Collaborator and Unified Communication Tool, and the Sippo Click to Call, the jQuery plugin for customer contact. And these are pre-built applications. The other option is to create a custom development based on these Sippo.js and also the Sippo modules that we have residing into the Sippo web. Okay, advantages and disadvantages about these two options is, well, the flexibility is better when you are using your the Sippo.js and the web modules, but well, it requires development. The Sippo pre-built applications are ready to be deployed and prepared. Okay, or it's maybe all of you already have tested them, but well, it's the pre-built applications. You could see that the gateway APIs are with less flexibility than the Sippo.js, and you say, okay, that's not well. It's different to say. Okay, what we offer here is that the Sippo.js is extended from the original Orca.js and the original Sippo from the original vendor libraries. So we included extra elements that are really important on the scenarios, and we found that they really necessary. And most of them you need to create it from the scratch if you are using directly the gateway API or external libraries. To avoid this signal complexity, we worked with different vendors. We tried to contact with all the WebRTC gateway vendors. We participate into the Sippo over WebSocket standardization that allow us to connect with all the SIP-based WebRTC gateway, but also with other proprietary, like for example, the list that is on the side. Nokia, Ericsson, Oracle, Broadsoft, Talkbox, and so Dialogic, and similar. Okay. About the browser complexity that we will see, well, on the final of the webinar, we will see the support currently of the Sippo solution. But if you want to understand a little bit the current scenario that there is today, you have well, the Chrome, Mozilla, and Opera that is implementing WebRTC from the very beginning, and it's implemented with fixed with the stable 1.0 WebRTC API, and also latest news say as well. Microsoft Edge announces that it supports natively WebRTC 1.0. Well, I'm going to put some emphasis on that, and I'm going to, well, I put here the Temasys Adapter.js solution, over the Edge logo, because what Edge do, what Microsoft do, is to create adapters from internally, natively, and they create adapter from the WebRTC REST or with the WebRTC API definition. They change them to the RTC API. So what they recommend, and it's something that comes from Microsoft, is to keep working with Adapter.js, and that was the solution that already get Quobis when we started to work with Microsoft Explorer and Safari, is to use the Temasys plugin of that it's the installable version of Adapter.js. So the recommendation is to keep working with Adapter.js, and that's what we are going to do. And well, other news, and also you probably know that the WebKit of Apple is developing the WebRTC API. So it's a matter of time that Safari comes to the green side and comes to the left to the WebRTC API support. We hope that when the WebRTC 2.0 appears, that they're working and talking about it, it will be something managed by all. But Sippo.js will be there just taking the different concerns on different browsers. The device complexity is based on, well, it's solved based on practice, on testing, and we create automatic tests end-to-end for all the features in order to try to get it as much supported as possible. And well, it makes hard, but principal points is that the UX must be responsive, and also the different problems with hardware must be solved. But well, possible to use on Apple, Android, laptop, desktop, also mobiles, tablets. Not necessary for different limitations. We use Cordova for the native applications on Apple, since there is no disclosed WebRTC API. And well, the push notifications are, well, we use the Google and Apple backend in order to send push notification. This is used for not only for notification, it's also used to create the wake up signal in order to put background running applications into the front. Okay, so we included and implemented the push notifications for that. The user management is also a problem solved by the WAC, since we can provision different user bases on different gateways. We can solve problems of we have come also do some projects with Federation of Authority of Authentication in order to connect with already existing Active Directories and so on. Another problem to solve by the WAC by the Sippo WAC is the security concerns, not only on the communication part. We also created, well, we worked in order to understand or to identify malicious scripts or malicious servers, applications that could intercept the communications layer, the WebRTC itself, and try to appear as a legal application, but they are not. So we try to get a second verification always on the communications in order to through tokens and other mechanisms in order to get this value. Okay, for authentication, this is a way to create a security element, a security mechanism that is to validate a token not only on the application level and also on the communication level. So there is on the lower part a token that is sent on the WebRTC level or the WebRTC plane, but also there is another token going to the app, from the client to the Sippo WAC, and we can confirm with the gateway through a secure connection on the DMZ setup on the demilitarized zone in order to check that that token is valid, and if that is valid, we can go ahead. On the Sippo WAC, we also gather statistics, we gather traceability, and we also have logs of everything that is happening. We also try to get information from the browser and from the client side in order to get info for troubleshooting and to confirm that the scenarios are working. We use it a lot during this presentation, the orchestration concept, because we think that it's crucial, the contextual information when you are working on web. When you are working on the voice, only the voice, like the legacy, well, the traditional voice over IP or PSTN, the voice itself is the context. There is no context on that call. The call just appears, and you need to have a different behavior with it. With contextual information, when you are on the web environment, you already have a lot of information previous to the call. So it's necessary to get the logging of the user that is inside the web page, all the things that have maybe on the shop chart, and maybe some forms that already were submitted from the user. All that things could be sent to the WAC, and they could be concentrated in order to feed big data analytic solutions or other third-party elements that could use that information. For statistics, we also have a small dashboard web interface in order to get details about campaigns, about agents available, about user browsers and devices in use, and so on. It helps for both for business and also for troubleshooting, as said before. And also the Sippo solution is prepared to be served on a scalability way and to grow up horizontally in order to create isolated, separated services and proxied by Sippo has high availability service in order to send queries to different services that could be required. So there is no single point of failure, maybe on the database or on the service WAC, and also on the proxy itself. Okay, so it's the structure that we have prepared for and tested for scalability and load balancing. Okay, as said before, this is more for telco providers. We cover part of the IMS standard where we developed the weak role, the WebRTC IMS client with the Sippo web collaborator and other applications built over Sippo JS. The WebRTC web server function that is, there is a part of the WAC that could serve the WAC itself could be used as a hoster of the applications, like maybe Apache or maybe Nginx or other web servers. We can provide a static context and where we can handle the applications itself. And finally, an authorization function in order to support the authentications with the ATT WWS. Finally, we are going to explain a little bit the family pricing for this 2017. And we licenses by applications, scenarios, and concurrent calls. So based on your scenario and use case that you require from us, you will have one licenses or other. So there is no. So if you want to create your application from the Sippo JS, you have a license for the Sippo WAC and maybe for the scenarios where you require support, Like for example, I want a desktop browser and Android application, for example. And that are application scenario and the concurrent calls. We call it concurrent call a connection from the Sippo endpoint to the Sippo WAC. So, for example, when you are talking one-to-one, there is two sessions established. When you are on a three-way call, there are three participants, there are three concurrent calls. And some extra integrations are applied for extra support and developments that were done during all this period. That it's the recording licenses, the HI licenses, and the MCU SPU connection to involve the communication to several multi-endpoints. Okay, so we are going to move to the next section, and we are going to start to talk a little bit more technical, and we are going to start with the basic context. We already summarized during this part the role of the Sippo WAC and has the application server the same as to orchestrate or to define to connect different elements, the identity management, authentication, and so on, third-party integrated elements integration with the term, the gateway stack, so all different ones, and also the WAC is an observer. It can troubleshoot, it can get details, it can get extra information. But what we are not is a WebRTC gateway. So we are going to be, we are going to explain a little bit how it's built. We recommend or we implement the product over VMware. Over VMware, we uses always a fixed scenario over a Debian 864 bits. That is the OVA images, the OVA image that we usually send to start the proof of concept and also to create the final production scenario. Okay. Inside this operative system, there is a Node.js engine, and inside this Node.js is serving, based on Node.js, there is the WAC engine. The WAC engine itself does nothing. It just manages all the different services, and the services itself are the ones that give us the different features. So when you launch the to prepare all the scenario to launch a Sippo WAC, you need something like a VMware or something where you can deploy an OVA image, and that image will have inside already all the system dependencies like Node.js, and it will launch a Sippo WAC, and that WAC, based on the configuration, will create the different services and the different services that work inside that solution. So the internal architecture, how it works, is based on services and backends. There is a main core that just launches all the different services and grants that they are alive and could send some core commands. But what is done in base is the service and the packets. The service is defined as a feature or what I want to do or what I want to provide, and the backend is how I'm going to do it, how we are going to implement that service. So, for example, like it's on the slide, the contact is a feature that we have in mind of different names with a URI to contact with that person or that identifier. And a backend is, okay, we are going to connect to Google and get the information from Google, the name and the URI that is stored into the file, into the field found. That is an implementation of the contact itself. Okay. So we structure all the features that we are going to see on WAC on this way. And we orchestrate and manage it based on a configuration file. The configuration file is the first requirement when deploying a Sippo WAC, is to check that this file is correctly written and it's correctly provisioned in order to launch the different services, and with that services, different implementations of what is required. Okay. So, based on this concept, we can create different scenarios. So, we are going to see one example here, and we are going to see on the next slide a different other example. So, this example is based on the use case that is the interaction between two web collaborator users, and one of them is sending the specific information. Okay, this is for a university in Belgium, and it's a research and development project where an ambulance is presented with a webcam or a high definition camera, and it's talking with a specialist or a doctor that is on the other side. So the other side is a doctor with just a web collaborator. It's not required specific software on the system, and it sends and receives data from the high definition camera, and also from other elements that are the recipes and the different machines that have on the ambulance real-time data that is fundamental for the user. Okay, so if you have in mind this map of features that we implemented on this scenario, the next example, I think that maybe you are already watching it. Well, the next example is a third-party context information. It changes the features uses, and here, well, we have a click-to-call calling to a contact center for service purpose. For example, to buy something, or maybe to contact the ID cell or the cable connection or whatever. Okay. As a result, the Sippo WAC is a WAC engine with all the services built over it. So we have different services, and these services are connected to different elements. That structure allows us to create different hooks, different breakpoints, and different implementations for the same things in order to be adapted to different solutions, maybe that are provided by the third-party vendors, or maybe for the specific customer requirements for a specific use case. Okay. Another important thing on the next slide is how we manage the users, and how we manage the user, the authentication and the different aspects of a unique user. When we are talking about a user, we are thinking on a person, and that person have different ways or different possibilities to be displayed. It must have an authentication entry, but it must have also credentials to use the WebRTC gateway. Maybe it have a photo and a portrait, an avatar. It also have different different business information that is required to be split. So we separated the users on 3 panels. One panel for authentication itself, other for credentials and WebRTC stuff, and a third party for business and profile elements. We're going to see this in detail on the next sections. So we also, talking about architecture or internal architecture, we can also see outside and see what we have on connections. We recommend usually to have 3 interfaces on the Sippo WAC in order to have one exposes to the on the left side, one exposes to the internet and to the WebRTC endpoints in order to send and receive the Sippo.js applications, the information that is sent through the WAC API, the WAPI, that is the connection between the Sippo.js applications and the Sippo WAC. And another internal or more dedicated to the core features on the right side in order to connect and use the Sippo connectors to maybe to consume REST APIs or so on, and also to send tokens and send authentication and verification methods to the gateway or maybe to connect with others. The third interface is recommended, and it's a good practice not only for this, it's good practice for everything to have a dedicated access for support and management, and specific isolated from the traffic that allows you to get inside the WAC, maybe if you are under a denial of service attack, or maybe through different problems that you could have if you share this communication with this role with the other connections. Okay. Well, the main important thing here is to define these 3 elements: the WAC API, the WAPI, the service API for the core application, this, the SAPI, and the Sippo connectors, the ability that have the WAC to get things from the other side. Okay. On the WAPI, the WAC API used by Sippo.js, as you can see here on the right of the diagram, you have your application that is developed over Sippo.js, and Sippo.js internally will split between things that could do with the gateway and other things that are required to do with the WAPI. So, for example, if I want to create a call, I will go to the gateway and send everything to the gateway itself. But if I want to maybe send an invitation for a meeting, or maybe to send a chat communication that is not supported by my gateway, I can send it through the WAC API, the WAPI, and be sent to the different services. Okay. So I think this is everything for the architecture itself, and we are going to talk a little bit about installation and configuration. Okay, we are going to go ahead with this part. We are already seeing the architecture, the internal architecture, and I made a specific emphasis on that we send an OVA, and that OVA is deployed on your lab. So everything on the website and the system part is already done. Okay. So what you need to have is, well, unless this hardware requirement. If you have an HR, you want to create everything for scaling, we prefer that you contact us in order to send you specific instructions for how to deploy the different elements and how to orchestrate them. And well, there is some basic requirements. We are working hard on LOAD testing in order to get all the bounds really well defined. But well, unless with one CPU core with 2 GHz and 2 GB is enough for basic tests, we recommend always for production 4 CPUs at 2 gigas and 16 GB of memory RAM, and the 3 network interfaces, and that will have, serve for 250 concurrent calls. It's tested at our lab, and it's okay. About network configuration, it's important to plan before to start and prepare the WebRTC gateway itself, which we can help with that task, and also to prepare your network security team. It's important because we are going to deal with connections, and it's necessary. We are going to require the 3 IPs. Maybe for proof of concept, maybe with just one will be enough, but for production, it's always 3 IPs. And we are going to deal with firewalls and networking using the town server. The town server is a mandatory element for WebRTC. Well, it's not mandatory on the theoretical part, because if you are going to get inside your network and you are not going to, if you think of a scenario where you don't have firewalls and you don't have NATs, it's not necessary. With an STAN is enough, or maybe using the different scattering and so on. But it's required the town server on a real scenario. So it's required to be installed and ready. And it's something that will proxy the media when we are dealing with double NAT, NAT on one side and NAT on the other side. Okay. So we are going to request some ports. We rely the signaling always to ports 80 and 443, almost on 443, because without secure connection there are there are a lot of problems with the browsers nowadays. That's good signal. So we rely to 443 for WebSocket secure and HTTP secure, and the town server will expose also the 443 and a range of ports in order to proxy the media in UDP. Okay, but will be only on the town server. When we are using the recording solution, when we want to integrate a recording proof of concept, we require to use a third-party recording server. Okay, we are exploring different trademarks. We have one right now that is our main partner for recording. And these third-party elements must be prepared. Okay, for recording, we usually deploy a specific server that mixes all the media and recorded it into a raw data, and that raw data probably requires extra configuration. We will see on the features part that all that extra manipulation that could be required, like store on different servers, prevent possible DMAS errors, prevent problems with identifiers and so on, requires extra development or extra things, just more than record itself. Okay. Sorry. Okay, here As I said before, we will do the deploy of the Sippo WAC over a VMware environment. We already know that some customers do this port to chain, key, KVM, VirtualBox, and so on. But well, the basis is to install, if you don't have the VMware, you have available the free instance for only one host of VMware. You can download it, deploy the OVA over it, and you will get your machine ready. There is some best practice recommended, that is to configure IP tables, configure all your security in order to do not get holes open. We usually are always on safety networks, but usually sometimes the WAC is exposed, so must be considered. Well, once the OVA is deployed, just launch the service. If it is not updated, we will provide you an update and the method to do it. And we configure the network itself that could be founded on the administration guide. Okay, you will have to access the machine. You will have you have a user called admin with Quobis, and this will help you to manage well, the network system fields and also some configuration like the WAC.ini and some other stuff in order to prevent from possible messes. Okay. There are some admin tasks that require sudo, and they are all of them contemplate. So trying with sudo, the thing that you want to do, it's probably that it's already allowed. Okay. So for instance, here is the WAC service itself to restart, reboot. To reboot the machine, to manage the routing table, to change different networks, and also to change elements related with database and so on. And also, of course, the WAC click that allow us to manage the WAC itself. We're going to focus now onto the base configuration when you are talking on a lab environment and we only have one IP. This is how the OVA is applied. You will receive it, and you just require to check into the WAC.ini file that is on this path, and you can check that your interface is serving on any IP of the machine, and it will be available to be using the port 8000. You will have the WAC there. So the OVA comes with a Sippo web collaborator, so you can launch the Sippo web collaborator and check that everything is ready. Okay. I added here some commands like the MongoDB restart and the service WAC restart that are the basic requirements. When we are talking about this is also to get in mind when we are changing the IP or when we are fixing the IP as a fixed IP. The files that you must change or you must to take in mind when you are configuring the network, like network interfaces, host name, hosts, and resolve is also contemplated to be edited under sudo, so don't worry about that. And well, do the pertinent changes, and after that, restart or reboot in order to get everything. But if we have three interfaces, okay, what we need to do is to create the, well, this is the VM information. It's not specific from the WAC. It is for the operative system. But you have to configure inside the network interfaces file. You need to configure both interfaces and also to include specific routing gateways for each of them, for both of them, okay? I think that I have a typo here. Yeah, I have a typo here on the route that is on the ATH2. There must be a different network. Well, the idea is that you must have a specific routing in order to modify accordingly your routing table, and you can check always your routing table always with route minus n in order to get all the information about these elements. Okay, we are going to go now with administration tasks. Okay, so we are going to try to go a little bit faster in order to get time for the different features that is the most new part of this webinar this year. Well, there is a file structure that it's good to know, and the important thing is that on the /opt/WAC there is the WAC clear C that manages the WAC clear connection with the WAC, and also there is another folders like config that includes all the configuration that is required to be edited by the administrator. Inside this configuration folder, there is authentication files, contacts, credentials, so out2, LDAP, and also the main core configuration file that is the WAC.in. Okay. There are also application-dependent folders like the click-to-call on meetings. So if you explore the file system, you will see these elements. So we are going to focus on the WAC.ini file on the next slide, just to define a little bit how it's going to work and how it works when talking inside of it. When you found there is one global section at the beginning with the log configuration, where you can configure the log level, and also to configure if you want it on a console, on a file, on a specific rotating file, or if you want both. Okay. But well, this is the global section. And after that, you will see the white faces. Okay, the white faces are the WAC internet. It's a network interface, but exposed by the WAC, and all of them you can configure up to 8 white faces, and those white faces will have an ID, and this ID will be used on the service definition in order to get clear where we are going to put that service. So, for example, on this example is the service www that serves the static content like the Sippo web collaborator application, and it have an ID, or it have a web face identificator, and this web face is public, and the public is the Wi-Fi is 0. The Wi-Fi is 0. It's well on. It's defined on all interfaces or all IPs. So what will happen here is that if you launch a request to an IP of the Sippo WAC, of the public key Sippo WAC on that port, it will be used or it will be responded by this service, okay? For this REST endpoint and so on. There are different services and it will have different configurations. But well, the idea is that is one service, one interface. The other part, as said before, is if the WAC is running as service and backend. Service is what I want to do. A backend is how I'm going to do that. So, for example, here there is credentials and different backends to implement that credentials. The credentials, for example, this anonymous limited to only Firefox users and maybe for Chrome users. We can create two backends, and these two backends will be managed in parallel by this service. Okay, so you will find this structure inside the WAC where you have services and a backend dot whatever. Okay. The main element to configure the WAC nowadays on the GA version is the WAC CLI. Okay. The WAC CLI must be served by the CLI service itself. It could be on an internal on an internal interface in order to allow only. You can put here the IP, or you can put a localhost IP in order to restrict only access from the interface itself, not from remote. Or you can open it to different external to the network in order to manage it from an external application, web external application, for example, like we do on the demo that we use the service API. Okay, but well, going to the topic, you must check when you are launching your WAC ini that your CLI service is enabled and it's served on the internal, and when you are outside on the wacli.rc, the wacli.rc file that is on the root of opt/WAC, you will find a wacli file and it will correspond one with the other. Okay? So when you launching the command that appears at the bottom, sudo bin/wacli status, it will appear some output like there is on the right side. Okay. So at that root level, the opt/WAC is where the wacli is checked and configured for connection. I added here a note about the insecure argument to add to the wacli commands when we are working with the self-signed certificates. Okay, and the examples will be with insecure in order to avoid this protection against not verified certificates. In production, you will not need insecure flag because you must have the proper certificates. Okay, what happens with this new version is that all service API actions require authentication since this 3.0 version. So when you launch the wacli, you will be prompted for a user and a password. Okay, all the requests must be authenticated through OAuth, and the WebCli is one of them, and you will need this user that appears on the user. Okay, username admin at Quobis and with password Quobis. I added here the insecure meaning because you have the self-signed certificates. There is a brief review about the WebCli commands, and you will have standard information on the administration guide. And well, there is the WebCli status, and also you will have the WebCli user command that allows you to create different users, the web users itself, and also to create the different credentials. As I explained before, you must have a user and different credential options. A credential for authentication with the web itself of that user, a credential to authenticate the user on the WebRTC when created some kind of methods on registering and so on, and also to create a credential for OAuth if you are going to do admin tasks and so on. So different panels of credentials will be considered here. We'll see a detail of that. Moving to the next section, the WebCli domains allow us to create different behaviors to different group of users and also to be expanded to multi-tenancy. The WebCli service, well, about domains, there is a default domain for most of the scenarios where only one domain is required, that it's Quobis. So that's the reason why there is a default user that is admin at Quobis. So you can create all your users basically with domain Quobis, and there's no problem. WebCli service allow us to monitor and check that all the services that are running from the WebCli configuration are properly running and working correctly. The WebCli migrate help us to move from 2.4 or 2.3 versions to this 3.0 version in order to adapt the database entries and so on. And the WebCli OAuth allow us to create this administration access for the SAPI. Okay, so we are going to go a little bit about what I need to create my first user when launching my Sippo web, and it's to create a user itself. So we are going to create a user called, for example, Alice, and you can add extra information here, but what is important is to include a different role, and I want to focus on this slide on the different roles. We have anonymous users, we have users or standard users that will use all the capabilities allowed by the application and also with normal users, and also administrators that could create this or that could make these actions over the core, the authentication, and so on. Okay, a standard user cannot use the WebCli, for example, and an admin user, yes. The anonymous user, for example, is different. It does not require. It's just a reference to a pool of resources or a pool of elements to be used inside the WebRTC gateway. It's an abstract user, and the user itself is somebody that it's appear and that it's able to create one-to-one connections. Okay, so first step is to create the user. WebCli user add minus u Alice, domain Alice at Quobis, and with the role user. Okay. Next step is to create this credentials for this user onto the web itself. So we are going to put a password for this user. And to do that, we are going to create the WebCli credentials add minus type, and the type is basic, and the basic is okay. The problem is that the help of this command is too large, and I needed to change from that. So we are going to use credentials add type basic, and the password minus basic credentials conejo, for example, rabbit. Alice at Quobis, password rabbit. Okay, so we are going to create a basic credentials. We are going to need another step, another command input to create the IMS or the WebRTC gateway credentials. These IMS credentials are not required to be exactly the same. So if you have already provisioned, I don't know, numbers, for example, if you have users available at your WebRTC credentials gateway from the 3000 to the 8000, you can assign Alice to the user 3025. So we can use these different parameters in order to assign these credentials, these IMS credentials, to the WAC user that is agnostic to all this stuff. Okay. Summarizing: add a user, add basic authentication, and add credentials. I used this slide also to explain the the templates. We use templates that you could find it inside the config/credentials folder, and this allows us to create all the different parameters already provisioned for the same gateway, for example. So it's usually that it's really common that you have one gateway and requires some details, like for example, you are going to have always the same A server, the same authorization server, the zip URI will correspond with your username, and so on. So you can use the template in order to put all the credentials and create commands like there are on the right side that are easy. I think that are easy commands and to create users maybe on a role, on a programmatic way, or whatever. Finally, we are going to talk a little bit about the database. We are using Mongo right now, and on this Mongo database, we store authentication entries, relationships, person's data, code statistics, and other stuff related with the data itself, with the WAC behavior. We are checking different other databases, and it's possible to create this on a separate machine. So if your customer requires to have a dedicated database on their network or whatever, you can talk with us. There's no problem to do that. Okay. For troubleshooting, contact us. Use the reference manuals. Check errors, logs on the files that are specified on the admin manual, and you can check some specific. Finally, we are going to summarize a little bit. What you need to check when you deploy your ROBA is check the WAC.ini configuration. Everything it's okay. Check that the static is with the static folder where we serve it. Change to port 80 and 443. Create at least one user and navigate to the IP that is assigned. By default, it could, but by default is that one. Well, there's last weapon, because I think the last of us are being sent with the HTTP. So, create your user and launch the application. I think that you already know the application. If not, you will see that on the right side there is the chat area, and everything is controlled from the left side panel, where you can check your contacts and also change to the different features, clicking on the right and on the left bottom part, on the left bottom icons. There is also the chat application, and you can chat with your partner that's directly from the contacts or from the display. Change your avatar and also your presence on the upper top, on the top left right side, where my chicken is here. And well, if you have any problem with the client, just told us. It's okay. Finally, well, I'm going to talk about features, and I'm going to, after that, go a little bit over the scenario support and release. I'm going to go a little bit fast over them, but it's nice to know or to have a little review about features that are available at the Sippo, in order to check with, well, if you have a necessity of, you have somebody that could require this, it's something to have an idea. There is a huge list, and we are going to go over them a little bit. Credential system. We have a service dedicated to manage credentials, and we change different backends that could be configuration around. So you can check also that the service, also that the user is valid for something that it's internal to the WAC, or maybe to something external, or maybe to something that is specifically that. So when the client on the right side gets credentials for something, for a user, it will receive credentials for all the things where it has capacity. So for example, it could have credentials for the WAC itself, but it could have for the gateway, for an LDAP, for an external service of whatever, and so on. Okay. Next, authentication system. We implemented the authentication system in order to get checks of that credential. So for example, I'm going to check that the password is valid. I can get inside the WAC on the middle, or I can go outside and check with an external or customer service if that user is valid or not. So for example, it's the case when you are using an LDAP or an external REST API to have these credentials. Okay. We use this for credential provision, so we can go to maybe to a web server, or to integrate with Google Contacts or so on. Validation system. We use them to get validations with different and also to get mechanisms to check that the tokens are valid, and to prevent malicious scripts to attack our platform. Okay. Federating identities. And the Sippo WAC feature allows to play the role of a client or maybe a provider. Okay, so we have all the logic of OAuth2 implemented, so we can consume external services, or we can validate users or applications For example, this the provided role is used, for example, when using the web CLI and also for the reporting interface. It's in order to get information from the auth and get authenticated. Contacts are are description of the web capacity to manage centralized address books, and it could be integrated with different backends and also with other third-party proprietaries. Here we make a huge development for mobile contacts. This is important in order to get your mobile contacts exposed into your application. The DAP for standard Active Directories. It's another way to get contacts and to get integration for all the previous elements. The user settings. The web provides a service that allows to the user itself to create extra information. So it's we use it on the default application for the avatar, for example, and for to configure contact info and business logic information. The group collaboration. We created two separated entities, the group to create a group of users and create commands over that group of users, and the rooms to change an action over a group entity, chat room. So we divided it on define groups of users and then do actions over that user. So when we are talking about chat, that is another feature, we can define to do that action over a room, and it will implement over different users. The present service is a classic presence with a table, local table, and also with external. With a local table where it's split in two tables, that is the presence and the subscription. Okay, and we also implemented REST API consumption to if you have something where your agents, for example, are already registered and you want to use that backend doing a small web service, we can interact with a REST API exposure for this process. The file transfer is a standard messaging that centralizes into the web in order to send one file, get loaded, and get the link to download it on the other side, and you can check the update status when it is being used. Sorry, this is the presence. Well, this is the file transfer. Okay. The data pipe is an abstraction of the data channels. When we started to work with data channels, we found that some vendors doesn't have that ability. So we implemented a service able to switch between the data channels implemented through the gateway, or maybe to create the same mechanism but through the web. Okay, it's used to exchange any kind of data between pairs, and it's used for different collaborative tools. The meeting service is a service that allows you to create and schedule a conference on the Sippo platform, and this service allows to invite an anonymous user, a user that is not logged into the platforms, like for example on a webinar or something similar, where there could be users that are anonymous. It could be receive an access to this platform, okay, or to create to this meeting. The mail service is one of the notification backends or one of the notification service, and is able to configure mail accounts and send mails for this, maybe for these meetings or maybe for other notifications like alerts and so on. It happens the same with the send SMS that is new on the 3.0 release, that we can notify through as an SMS to the STN devices. The push notifications is another kind of notification, but it's also used for to create this wake up signal to receive calls when you are on the background. Okay. We are still under development of some details that doesn't go so smooth as said. The click-to-call service allows us to manage the calls when they are received when the calls from a click to when a request from a click to call that comes from an anonymous user, it could be served with more services or maybe with a fallback. So this feature allows us to create a lot of business rules or business elements that allow us to create different scenarios that my colleague Marcos will explore with you. The web campaigns, there are some of these, one of these business logics that are used on the click call, and there are defined pools of users and defined schedules of hours in order to receive or not receive a call and to route it correctly or not. Web forms is used to exchange JSON information between the two pairs and also to get visual help when you are user filling a form and the user could be confused and the support on the other side could help. The recording solution, as explained, it enables the call recording. It's implemented through a third-party element, and this feature is completed with post-recording processing. And the post-recording processing includes to solve video problems, concatenation of videos, index of videos, and also to send it to a remote storage or definitive storage. And also there are other customizations that should be required over the video itself. The WebRTC stats, the WAC have the ability to get all the statistics and core and carry the core of the browser periodically in order to get evolutions of this data and send it to get processed. The call routing, as said before, the call routing is the main service that allows how to manage the call based on multiple context elements. Okay. It involves a series of services, and it could trigger multiple call hooks. So what we divide it is in steps, and when a call arrives or a request for a call, that is more important than the call itself. The request for a call arrives, we can have one behavior or other based on different services that we have, and also based on different developments that we can implement over it. But we already defined the points where you can choose and you can move. That gives us the ability to expand and also to be customized to get fit onto the different solutions. The call queues routing, for example, is evolved from the campaign feature, and it's required when it's for route through different agents of the pool, and so on. Okay. So this was a brief, fast way through the different features. We're going to talk a little bit about the scenario support and finally about the release 3.0. About the scenario support, we make tests over most of the platforms that are used or being used on the market nowadays. So we currently have desktop operating systems with Microsoft Windows, Apple, and Linux, and also mobile environments with iOS and Android. Where on the mobile environments we have two solutions. Well, with Android, you already know that the browser could be capable if it is on the is recent or it's modern and your hardware is enough. But we have solutions based on apps, maybe native, completely native, or maybe hybrid, that are, well, 50-50. It's Cordova based, both applications, but well, the hybrid application is based on Cordova, and the native is native itself. No? There's nothing to do with that. Well, the main modern devices we tested it over main modern devices, so it will know it should not be a problem to check if it will work on one mobile or not. Of course, there is limitation of hardware, and it could result on maybe video that it's not properly shown or it's not smooth enough. No problems. We included here two slides with some charts of compatibility. I'm going to talk here a little bit about codecs. And the codecs will integrate on the browser implementation and the WebRTC gateway capabilities. But when we are talking about WebRTC and we talk about go with the same codec in order to do not do transcription, most of the time the most consuming is the end-to-end encryption. Okay, so when you have the WebRTC environment is secured and the security is a priority on WebRTC, so you could not send like a pass-through directly to the media to the other side. But well, Opus H264 it's available at all platforms. G711 is related to Chrome, Firefox, and Android and desktop environments. Browsers. We have, I say there a complete production coverage because we have a solution for all the scenarios that we founded. Okay, there are some ones that we have limitations on platform, like for example, when we are talking about Internet Explorer 8, that it's only for Windows XP. Well, other platforms like Windows Mobile where we do not develop. But most of the scenarios that we founded with, it will be covered with a solution over it. And what about Sippo release 3.0? What we can expect? Well, the main objective of this release was to create a solid rock. The code name of the version was solid rock, and the idea was to get to get really focused on stabilization and to work on architecture and HI and stability and high availability. And we create very big improvements on that side. Also, the service API is more secure with the authentication requirement, and also we have improvements on the applications itself. The Sippo WAC is it provides new features like extraction of the MCU or SFU integration that will have. It's not reflected right now on the web collaborator, but it's, in the SFU integration will be founded or will be reflected on the next version on the web collaborator. But the MCU is something that maybe all of you were already tested, and it's a reality. The room events storage in order to create rooms and store the information that is shared from that room. The SMS backend for notification of meetings, for example, and other notifications, and also the Docker-based deployment system. Well, this is something that we are on the Sippo web collaborator. We put the meetings with the SMS. We create the group collaboration. In order to create on a chat room, you can also share a whiteboard or a form. We extended the group collaboration from only chat to also the different collaborations with the different tools. We include the MCU. The SVU is done on the web, but not exposed here on the web collaborator, but the moment, and also with auto-logging. This is very important when we are talking to integrate this the web collaborator on another portal. If you have your communication portal with all for your employees and you want to integrate the web collaborator, you do not need to log in again. You just do auto login based on tokens, based on auth or something. Also, the click to call get new features like the CAPTCHA protection integration, media selector of the customer side, or during the call you can change from the front camera to the back camera of your mobile phone, and also to include a dial path to navigate through URLs. This was done for some customers that require to connect to the click to call on a voice only to existing interactive voice response, and it's easy to get integrated there. And some improvements. Okay. So I'm going to finish here. Sorry, I get a little bit over my time, there's minutes more, but I hope I have a comparison of the work, and if you have any question or any problem, do not hesitate to contact us or submit your question about this part. I'm going to put the speech onto Marcos' hand. Marcos Perejo will give you through the demo platform visit that we are going to do.
Okay, thank you, Santiago. I am in charge of the demo platform. Now I will talk first about some critical use cases, and later I will introduce Sippo Demo Admin. The Sippo Critical is a simple API that it is used to create button web pages. And you can do it with only a few lines, maybe 10 lines only. This one is the standard critical. We use it to show the main features in this application. The first one is the setting area. you can see the setting area on the left part of this web page. This works in the following way. When the agent put a multimedia link in the chat, it will automatically display on the setting area. The information that we can display is images, videos, and PDFs. The second feature is phone sharing. If the agent is seeing a phone, he can share it with the client, and both partners can fill it at the same time. We also have screen sharing. Both partners can screen the complete window, the complete screen, or only a window. And the last one is the whiteboard. If the agent activates this feature, both partners can draw in a video on the web page. This demo is simulate an energy company. The client choose a bill, and in some point he has some doubts about it. So he called the agent, and both partners can use the whiteboard with a background. This is the client view, and this one is the agent view. The next demo is a SOAP. We use PrestaSOAP for this demo, and we create a plugin very easy to use. We have a background, a back office to change, for example, the destination of the call, and when the user pushes the click to call button, some additional information is exchanged with the agent. In this case, we can see that the customer has some objects in the shopping cart, and in the next page we can see that the agent is seeing can watch the web page in which the customer is in this moment, and also the content on the shopping cart. The next demo, okay, now is the second part of the Quobis demo. In this part, the user wants to authenticate, wants to validate himself, and for that he used his mobile. So we make use of Mobile Connect for this. So he has a phone. He put his phone there, and later he will receive an SMS. He click in the link in this SMS, and he will go to a web page in his phone. The web page will ask for the consent to take the user details, and later a call will be established between the customer and the agent. And the information that will was retrieved for the Mobile Connect platform will be sent to the agent. In this image, we can see that was retrieved the name and the email of the Mobile Connect platform. But in the future, we will retrieve also some more fields, like the address or the personal ID, for example. This demo is a social TV platform. Here we can see a main video that is retrieved from a CDN platform, and it is displayed synchronized to all the participants. And if another participant enter in that room, he will go synchronize with all of them. Now I want to show you the Sippo admin platform. It is used to manage the work and to create some demos. It is a modular platform. It is organized in apps. For example, here we can the Authentication Authorization app, the Campaign app, Create to Call app, User Manager, and Work app. Also, we can manage several works at the same time and several gateways. The main feature is to create work accounts. In only a few clicks, we can create an account for a web gateway that we can choose. Also, we have some additional information. For example, here we can see who created the account and when. Another application is the Click to Call. It's based on templates that we can customize. For example, we have a field that allows us to change the CSS style and also to add some JavaScript code. We also can change here the company logo and the destination of the code. Now we are also adding here the capability of create campaigns and also to put in the campaigns some forms. In this case, for example, we have an agent form that will be displayed to the agent, and he will be able to share it with the client. And also we have the satisfaction form. This form will be displayed to the customer once the call is finished. This is all from my part. Thank you for your attention. And I think that
okay, we are running out of time. Maybe if you have any question or any problem with the presentation, don't hesitate to send it to us. We will publish the slides and also other related information through our partner channel, and we're happy to attend any question or any problem that you have. Thanks again for your attention. Thanks, Marcos, for your demo part. And request your demo if you didn't test it. Contact with us if you are interested on some specific feature or some specific part of the product itself. Okay, thank you for assisting.